Hey, welcome back for part two of Binomial Distributions Day 1. We're still looking at statistics packet page 16, and we've just kind of introduced what it means for a probability distribution to be about a binomial experiment. Two possible outcomes, success or failure, hit or miss, fixed number of trials, we'll call that N, and the trials are independent, so you always have this constant probability of success, and if you take 1 minus that, you get Q, the probability of failure. This formula is useful, don't get me wrong, because it will calculate a probability in any binomial distribution, but our calculator gives us a quicker way. So we were just getting into was this new notation with this SAT problem of binom PDF, and there's another one called CDF that we'll go over. If you shift down to the bottom, we said it was second and then the distribution key, DISTR on the calculator, and you go down to letter A is going to be binom PDF, probability distribution function, PDF. And then in a second, we'll get to letter B that we're going to use that you see to the side here, binom CDF. The C stands for cumulative, and both of these. So we've actually done a couple of this one, and we'll review it in a second. These two are going to come in handy, but for now, can you cross off? I made an error in how I typed this one, so we're actually just going to amend this in a second for that shortcut. So I guess if we've already answered 7 and 8 about getting a certain number of SAT problems correct with this setup from part 1, we could probably get 9 and 10, an amount incorrect, right? I could say this one is going to be a binom. I'm going to use this as the work that I show, what I type into my calculator. So a binom PDF. Still have 25 questions that we're trying to get right or wrong. Probability of getting 6 incorrect. Well, that would mean if the probability of getting an answer correct is 0.2 and you have 25 total, 6 incorrect, right, should mean you're getting 19 correct, right? If 6 are incorrect and 25 total, 25 minus 6 gives you 19. This would be one way to get 6 incorrect. Another way to do it would be to change what you call success. To me, success is you getting an answer correct, right? That makes sense in my brain. But you could shift the experiment and say success is that you get an answer wrong. If you call P the 0.8, your probability of getting an answer wrong, and put a 6 in here, you'll get the same exact answer you would either way. So go ahead, try to type it in with a PDF. You can use those shortcuts that we just talked about and see if you get about, something really low. 6 incorrect is 2.43 times 10 to the negative 9th power for that exact experiment. Same thing for the next one. 2 incorrect, I'll just set it up one way. If I'm only getting 2 wrong, this is really good news for me. This is a binom PDF, 25. I have a 0.2 chance of getting an answer right, and I want to get all but 2 of them right. So 25 minus 2 gives me 23 correct. We could also set this up with a 0.8 and a 2. Pause if you want to try typing it in, see what answer you get. You get a 1.611 times 10 to the negative 14th. Okay, so that would be those are good examples of how you could use the binom PDF. And now I want to circle 11 and 12, the last phase of this. 11 and 12 are speaking of more than one case. At most 15 correct and at least 20 correct. I want to think about this situation in 11. At most 15 correct. What cases are we adding up here? This is like saying the probability that I get, since I can only get a discrete number of problems correct or incorrect, I get 0 correct, right? That would be the lowest amount I could get correct on that test. What's the next amount? I could get 1 correct. Another case would be that I get 2 answers correct. All the way up through, what's the last case we care about? At most 15. P15 there. So I want to add up all the cases from getting 0 right, the lowest amount, all the way up through 15 right, and I don't want to have to type in binom PDF 15 or 16 times. That's ludicrous. So here is where we use the cumulative distribution function, and an at most question is made for a CDF. This is perfect. You can type in your number of successes, probability of success, or number of trials, probability of success, and then this is going to add up all the cases from 0 to X, since C stands for cumulative. So that is perfect. It's going to be a huge time saver. Here's the work you show, binom, can you say CDF instead of PDF? And let's still do 25, comma 0.2, comma 15. We're adding up all the cases from 0 through 15, and we'll let the calculator do the work. So second in vars for distribution, I want to scroll all the way down to letter B here, binom CDF. Same setup though, you still want to type in 25 trials, comma, probability of success, 0.2, comma, the case you want to add up to, 0 through 15. We'll put 15 there, enter. You'll see the notation of it. Enter again gives you almost 100% chance that you're going to get at most 15 correct. So man, when I round, it basically rounds to 1. I'm going to put 5 nines and then maybe an 8 afterwards when rounded. So a very, very high probability of this occurring for an at most. How about an at least? And this is the one where I have to change my notes for you a tad. At least X successes, can you rewrite this? What I should have had was what was typed here with a 1 minus. And we'll talk about why this is what it is. But it's 1 minus binom CDF of n, comma, p, comma, x minus 1 for some reason. This is one I want to use for an at least, which we see coming up a lot. Always like in probability, going to be a 1 minus. At least 20 correct. Let's talk about this for a second. So for at least 20, that's a few cases that you're adding up. 20 at the very least. So the first case is going to be probability you get 20 correct. You get 21 correct, 22, all the way up through 25. 23 counts, 24, and 25. I say in blue here, these are all the cases that fall under that category of at least 20 or more. So how could we use a binom CDF? Well, if I'm not interested in adding up 6 PDFs, right, that would take too long. Think of all the cases you're leaving out. You're leaving out a cumulative distribution from 0 to 19, this x minus 1, one less than that at least 20 that you desire being correct. So I'm going to type this in as 1 minus the probability adding up of all the cases that you want to leave out. You want to leave out a binom CDF of 25, comma, 0.2 still, and I want to leave out up to 20 minus 1. So for that final number, right, that we'll add up to, let's put that in as a 19. And we can use the calculator to estimate this. So we're subtracting all those cases we want to leave out. Let's type it in as a 1 minus. Now let's pull up binom CDF. I noticed these like Poisson distributions and geometric. The Poisson ones remind me of fish, right, in French. And then binom CDF of 25.2 looks good. And I want to leave out all the cases up through 19, one below 20. Type it in, and you get something low again. 1.94 times 10, we'll say, to the negative 10th power. So that's the idea. We get to practice with this over the next couple of days. You'll see a lot of binomial situations. The key is when you've got an exact case, like exactly 15, exactly 3, exactly 6, you're always using a PDF. Versus these at least and at most, we're going to talk about strategies and ways that we can use binom CDF to our advantage. Next page has some really good practice for us, so let's end by talking about none other than Bryce Harper as we turn to page 17. His batting average currently is a .276. That means 28% of the time he goes up to bat, he gets a hit. And we're doing an experiment where we look at his next 300 at-bats and finding probabilities. Have the calculator handy for this. What's the probability he gets exactly 20 hits in 300 at-bats? So exactly 20, when I see that word, that makes me think of a PDF, probability distribution function. So binom PDF could be the work that I show. In this case, think of NP, and then X will vary for the problem. So N is your number of trials. I want 300 at-bats that we're looking at. Probability of success, let's say success is he gets a hit, so .276. And an exactly 20 would be a comma 20 at the end. Go ahead and type that in. So second distribution, binom PDF, and let's use 300 at-bats this time. Probability of success, .276. And then X value, we want 20 exactly. So hit enter, see the setup, and we get that this is a low probability. So 2.63 times 10 to the negative 20th. Pretty unusual that that would happen. Okay, now, exactly 80 hits. We'll do this setup. You can check your answer with mine. Binom PDF again because it's an exactly case. All right, so maybe he'll have better odds of getting 80 hits, 300, probability of success, and then we'll type an 80 in there. Pause, type it into your calculator, see what it gives you, and see if it's a bit more likely. Not too much more though. 0.0487 when you give it 3 significant digits. There is this informal rule I can tell you about that says that if you get a probability that's below 5%, so below 0.05, they call this a statistically rare event. We're going to say it would be rare, just misses the cutoff for a usual event, that he would get exactly 80 hits and 300 at-bats. Now, what about these at least and at most? Okay, let's look at 15. At least 100 hits makes me think of a CDF. Well, that would be probability of getting 100 or more. 100, 101, 102, 103, all the way up to 300. So we want to do a 1 minus anytime we see at least. 1 minus a CDF. And if you need to remind yourself, you've got the shortcut steps on the last page of the packet. Let's subtract a CDF of still 300, same probability of success, 276. Add them all up to 1 less than 100. That's the last case we want to leave out, so we'll put a 99 there. That should do the trick for number 15, a 1 minus a CDF. So I'll go, sometimes I just hit second and enter a couple times, so I could just bring up the past previous entries. I'll just edit what I already had here. 1 minus a CDF of, let's say, 300. This time I'll use the comma key, so right next to the parentheses, 0.276, and then comma, we want to add up to 99 and subtract those off. So hit enter, and you get a 0.0168. So around that, 0.0168. So about a 2% chance, definitely a rare chance of that happening. Can you add a 15B here? Last but not least, what if you see a no more than? So we'll say no more than, and we'll pick a number, let's say no more than 80 hits. Because both of these cases have like an at least, a no more than, you're adding up certain possibilities, a CDF is going to be useful here. And this is just like an at most. A plain CDF would do if you think about the cases that you care about here. So what do we care about? Well, we care about no more than 80. So what's the lowest? 0 hits up through 80 and no more. Let's just do a straight binom CDF for this last one. Whoops, CDF. And then start with 300. Probability of getting a hit, 0.276, and we want to add up all the cases through 80. So it's the same setup as number 14, just with a CDF instead of a PDF, if you see that terminology. So try that with the CDF, and you can pause the video and try it on the calculator, but check your answer with this one, a 0.387. So not statistically rare. When you do a CDF, we'll say here, up to 80 hits, I would say it wouldn't be rare. You have a 38.7% chance. Go Phillies! I'll talk to you guys soon. See you later.